Hello. So when we think of an angle, we usually think of that little space between two lines. This is angle, or commonly known as theta. Just draw them like that. A circle with a line through it. It's a Greek letter. And we tend to measure, or as you may have seen, we tend to measure theta in degrees. This is theta degrees, right? Or x degrees is equal to theta. Some degrees is equal to theta. It's not necessarily theta degrees. Theta is just the name of the angle. And our degrees go up to 180, right? You can go all the way around. 360. It goes to 360 as a full rotation, which means there's 90 in each corner and 180 in each half. And 360 is great because it's divisible by all kinds of things. 120, 60, 32, 180, 90, all kinds of, 45. There's so many factors. But besides that, it's not exactly relevant. It's just kind of an arbitrary thing. Sure, it's 360 all the way around. That makes things a little easier, because you can divide it by, 4, 2, 3, and, basic integers, but it doesn't say anything about the circle itself, which is what it's rotating around. 360 degrees is in a circle. These degrees work within a circle, even if it's an imaginary circle. So, is there possibly a way to measure this that is actually relevant? Let's see. So obviously I haven't come just to show you that your system is wrong. I've actually come to introduce a new one in its place, and it's called the radian. The radian measurement, you could call it. Where every radian, which is what you measure what you use instead of degrees now, has an arc length of the radius of the circle. What does that mean? So let's say we have let's say this is 1 radian. We have 1, we can write radian. And our radius, which is the same everywhere in the circle from the center point, that's what the circle is. We have 1 radian is how many degrees you've gone around. And the point of the radian system is to make a connection between how many radians you've gone, how much around the circle you've gone, and the arc length you draw. So imagine that like there was a pen at the top of this arm that you're sticking out, and it's drawing a line. How long is that line that it's drawing? So what is this x? Let's call it x. So, as I said, 1 radian has the arc length of the radius. So x is equal to r. Well, does this apply for other multiples of radians? Well, yes. A radian just mentions how many radii of the circle's radii are in the arc length that it travels about in the circle. So if you take 3 radians, which is around here, you take 3 radians, this entire distance is going to be kind of hard to sketch. This entire distance is going to be 3, so this new x, x2, is equal to 3 times the radius. It's that simple. So how much is in the entire circumference? Well, circumference is what? The circumference around the whole circle is, as we know from geometry and can prove easily with calculus, but harder with geometry, is 2 pi times the radius. So, because our arc length using this length, the arc length is equal to the number of radians we've gone times the radius, so it's just kind of theta times the radius. How do we, if these are equal, what is our theta? R on the side. So theta times r is 2 pi times r. Well, that's a bit obvious. 2 pi is equal to theta. Our theta, for all around the circle, all around all the way around, if I can make brackets that extend around all the way, I would. This is the theta. Our theta is going all the way around, but this is the circumference. Theta goes around 2 pi times. So instead of restarting the cycle at 360, we restart the cycle at 2 pi. And 2 pi times the radius is the circumference. So this is great. Now we have a degree system that is not only somewhat easy to divide by. It's got pi in it. Pi is a fun number, but it has a lot to do with circles, which is why it's there. But it actually tells us something more about the circle it's in and the curve. It's not just an easy arithmetic tool. It's actually helpful in geometry, too. And I don't mean that degrees aren't helpful in geometry. This one's just more so in actually measuring distances. So, 2 pi radians, I'm going to write rad, is equal to 360 degrees, and 1 radian is, what is it? Well, that's what we're going to investigate in the next video. How exactly? And yeah, it was pretty easy with the circumference because, you know, the circumference equation is easy, and finding smaller distances isn't too hard either. But in the next video, we're going to compute and translate some units. Thanks for watching.